Okay, so lesson 54, we're going to talk about how to graph parabolas. So we first need to get the equation in this format right here. Y equals x minus h in parentheses squared plus k. So when it's given to you in that form, it's fine. But if not, then you have to complete the square and get it into that form. So when you're in that form, what does all this mean? If the sign right here is positive, it means it opens up. If the sign right here is negative, then it opens down. Okay, it says this tells you what the axis of symmetry is. You set this equal to 0 and solve for x. So x equals 2 is the axis of symmetry. This tells you the y coordinate of your vertex. Now your vertex is going to have the axis of symmetry coordinate as its x. So the vertex is going to be at 2, negative 2. So to find where it crosses the y-axis, that means where x is equal to 0. Then what you want to do is you want to set x equal to 0 in your equation and solve for y. And you can plot that and then label it. And then find where it crosses the x-axis by putting in 0 for y. So when you put in 0 for y, then you need to solve this for x. So bring that over, take the square root of both sides, and solve. So that's what you do to get ready to graph it. So let's see what we're going to do here. Okay? So remember, the axis of symmetry is x equals 2, the vertex is at 2, negative 2, and it opens up. So what you want to do is draw your graph, draw your axis of symmetry as a dotted line, and label the equation of that up here above it. Then 2, negative 2, we know is the vertex, so put that point there. Now you found some other points too. You found this point right here, that when x was 0, y is 2. So that point is 0, 2. Plot that one. It's always going to be symmetrical about that axis of symmetry. So if that point is on there, so is that one. And then these 2 points are the 2 points you found when you solved, when you put 0 in for y and solved for x, which is where it crosses the x-axis. So it crosses at 2 plus the square root of 2. And at 2 minus the square root of 2. Now the square root of 2 is about 1.4. So 2 plus 1.4 is about 3.5. Okay, so 1, 2, 3, about a half. And 2 minus 1.4 is about a half. So I plotted there at a half. But now don't use those estimates. Use the actual numbers like this to label your point. And then you just draw your parabola. So the key is that it's got to be in that right form. This is called the graphing form. Okay, in order to graph it. Okay, let's move on to 55. In 55, it talks about circular and distinguishable permutations. So it says, Euclid and 4 of his students sat around a circular table. So that's a total of 5 people. How many seating arrangements were possible? So let's just put Euclid as a spot. Okay? Now the fact that I chose a spot for him to sit in means there's only one person that's in that spot. There's only one person that could be in the spot that I chose for him. So the first spot had 1. Now it doesn't matter where you go next, I'm just going to go around the circle. The next spot, I had 4 choices, then 3, and then 2, and then 1. And so there was a total of 24 different arrangements. So if you have 10 people seated at a round table, how many ways can they be arranged? Okay, so following the pattern you see up here, the first one will be a 1, because you have to start somewhere, so you chose that one. And then 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. It's the same thing as 9 factorial. So if there's 10 and it's round, it's going to be 1 less than 10, 9, and factorial. So you get 362,880. Okay, so here it says how many distinguishable permutations can be formed from the letters in the word Sassy. Okay, well, we have an S and an A and a Y. There are 3 S's, there is 1 A and 1 Y. So what you put is you put the total number of letters, which is 5 in the top, make it factorial. Then think of these as individual categories. So for each one of those, the number of S's, the number of A's, the number of Y's, you're going to put that in the bottom, factorial. And then just simplify that, and you'll get 20 on that one. Okay, here it says there are 3 identical black books, 5 identical blue books, and 4 identical green books. How many different patterns are possible if the books are arranged on a shelf? So there's 3 plus 5 plus 4. That's 12. So you put 12 factorial at the top. Each category, you've got black and blue and green. There's 3 and 5 and 4. So do each one factorial and just, reduce this out, and you'll get 27,720. Okay. See, these are called distinguishable permutations because if I have 5 blue books, I'm not going to be able to tell the difference in them. So you have to talk about distinguishable ones. Okay, now let's look at 56. Let me get some right on good. Okay, it says find the area of this triangle. So what we're going to do is we can look at this triangle, and we know that area is 1/2 base times height. We know the base is 124, but we need to get the height. Well, the height is the altitude, so you need to draw a perpendicular line down to the base. Now that luckily creates a right triangle. I know this angle is 56. I know this is 138. Now this 124 goes the whole distance. So I don't know how much of it goes there, so I can't use that. But I want this. I want H. So if you look at this, I want to find opposite, and I have the hypotenuse. So the sine of 56 is going to be H over 138. Multiply both sides by 138, and we're going to get H. Okay, so what you want to do is you want to put that number in there, whatever that is. I would just, put this in my calculator. 1/2 times 124 times 138 times the sine of 56. And when you do that, you can get 7,093.25 feet squared. Okay, so let's do another one. This time it's a trapezoid. We know that the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, now I know that the bases are my 7 and my 9. So 7 plus 9 for the bases. And now I need to find my height. Again, height is altitude. Again, I've created a right triangle. Again, the 9 is this whole distance, so I can't use that. But I have this angle right here, which is 42. I have this, which is the hypotenuse in the triangle. And I need H, which is the height. So I'm going to say the sine of 42 equals H over 7. So 7 times the sine of 42 is what H is. So it's going to go there. So put in your calculator 1/2 times 16 times 7 times the sine of 42. And you're going to get 37.47 feet squared. Okay, let's go to the back here. Number 3 says find the area of a sector with a central angle of pi over 2 and a radius of 6.2 kilometers. Round your answer to 1 decimal place. So I know that the area of a circle is pi r squared. I don't want the whole circle, okay? How much of it do I want? Let's think about this for just a second, okay? I want a central angle of pi over 2. Pi over 2 radians is 90 degrees. So this is my central angle, and I know that my arc is equal to the angle, if it's a central angle. Has a radius of 6.2 kilometers. So I don't want the whole circle, but I do know I want a part of it. I want, and you can do this in radians or in degrees. I'll do it in degrees first. I know that's 90 degrees, so you can do 90 over 360 times pi times r squared. You can do that. Or you can do pi over 2 out of the entire circle in radians is 2 pi times pi times 6.2 squared. If you do it this way, these pi's are going to cancel, okay? Anyway, you look at it, you're going to get 30.2 kilometers squared when you put in your calculator. Okay, let's look at number 4. Number 4 says find the area of the segment bounded by an arc of measure 100 degrees and the chord joining the endpoints of the arc in a circle of radius 9 feet. So we need to draw this. Okay. 100 degrees, that's more than 90, right? So let's make one makes it look a little bit more than 90. So 100 degrees here. It says find the area of the segment bounded by an arc. So it's bounded by this, it says. And the chord, this is the chord, that's joining the endpoints of the arc. Okay? Now, I know that this arc right here has the same measure as this angle. Okay? What I want, though, is I want the area that says of the sector. I'm sorry, of the segment. And I know the area of a segment, let's do this, equals the area of the sector, which should be the entire thing. So the entire sector is all of this. All the way out to here is the area of all of that. That's what a sector is. But then if I take away the area of the triangle, so if I take away out of this sector the area of the triangle, I'm left with this right here. Okay, and that is called a segment. Now it's a segment in a circle, but it's not like a segment which is a subset of a line. Okay, so I know my area of the segment then is going to be, so I want to get the area of the sector. Well, it's 100 degrees out of 360 times pi times r squared. It says the circle of radius 9 feet. So these are 9 feet. So 9 squared is 81, right? So we got this minus the area of the triangle. So what do we have here? We have a triangle that looks like this, where this is 100, this is 9, and that's 9. If I want to get the area of a triangle, I know I'm going to do 1/2 times the base, which is 9, times the height. But I got to get the height by doing a perpendicular segment. So you extend that base out, although I'm not using the length of that, I extend it out in order to create my height. So this is going to be my height. If that right there is 100 degrees, sorry, that right there is 80 degrees. So I know I can say the sine of 80 then is going to be equal to opposite over hypotenuse, which is h over 9. So then my h is going to be 9 times the sine of 80. And that's what is going to go back over here. Okay, so put all this in your calculator, and the area of your segment then is going to be 30.80 feet squared. Okay, now let's graph some inequalities here. This will be fun. So you want to draw an XY axis. This is a parabola. Okay, so what is this? What do we know about this now? We know that the axis of symmetry is going to be x equals 1, and we get it from that. So that equals 0, and solve. We know that the vertex, the x is going to be a 1, the y is going to be negative 1. It's positive right here, so it opens up. So let's find where all this is, okay? So I've got an axis of symmetry of 1. So I'll move them apart a little bit so you can see better. And that's my axis of symmetry. My vertex is at 1, negative 7. That's going to be right here. I need to find where it crosses the y-axis. It'll cross the y-axis when x is 0. Now that's pretty easy. You can just sort of put that in and do it in your head. Negative 1 squared is 1. 1 minus 7 is negative 6. So it's going to cross right here. And remember, they're always symmetrical, so I can come over here to 2 and put 1 at negative 6. Now for me to find where it crosses the x-axis, that takes more time. I've got to put a 0 in for y. So I'll do that. If I put 0, and I'm just going to change that to an equal for right now. X minus 1 squared minus 7. Take the 7 over. We're going to take the square root of both sides. I have x minus 1 here, and I've got positive or negative square root of 7. So x is going to be 1 plus or minus the square root of 7. Now, square root of 7 is between 2 and 3, because the square root of 4 is 2 and the square root of 9 is 3. It's probably closer to the 3, but it's not quite 3. If I think of it as a little bit less than 3, 1 plus 3 is 4, so it's going to be a little bit less than 4. So I got up to 3 here, a little bit less than 4. And 1 minus about 3, but not quite. That's going to be a little bit more than negative 2. And let's see if that makes sense. So if I go 1, 2, and then some, I go 1, 2, and then some. Okay? So what we want to do, now this is greater than or equal to, so it will be a solid curve, the line, not a broken line. But it's greater than that. So the way to think about that is just think of the vertex. That's the lowest point. Okay? Numbers greater than this point are up here. So I'm going to shade all of this. That means everything on the inside gets shaded now. Okay. Alrighty, now let's draw the line. So it goes through at negative 6, so it's going to go through right here. It has a slope of 1 over 1. So let's see. This is 1, 2, 3, and 4. So if I go up 4, 1, 2, 3, 4, then I would be over here. Right? So now I can draw my picture. And this says less than or equal to, so the numbers less than these numbers are down here below it, right? So where it's going to overlap is right in here. So this is your answer, is this area that it overlaps in. Now, although I would normally be coloring everything below, I'm just darkening where it's overlapping here. Okay? So let's look at this one right here. This is the equation of a circle, isn't it? So this is a circle. It has a center of negative 3 is 0, the opposite of that, and of course a 0. It has a radius of 5. Take the square root of that. Okay? This is a parabola. It opens up because it's positive. The axis of symmetry is x equals -3. Now this doesn't have anything here, so it's like plus 0. So the vertex then is -3 and 0. So I need to draw me a graph where I can graph all of this stuff. Okay, let's see. I'm going to give more I'm thinking more into this quadrant is what we're going to need. So I hope this is going to work out. Don't be messing it up too much. Okay, we're going to do the parabola first. 1, 2, 3. Do our axis of symmetry. We got our vertex is at -3, 0. It opens up. I can find where it crosses. If it opens up, it's only going to touch the x-axis there. And I can easily find where it touches y by putting a 0 here. So that's 3 squared, so at 9. So these scales are going to be off, of course. So this is a 9 here. So it's going to cross here. And if it crosses there, then it must cross, and that is an or equal to 1, 2, 3 over and 9 up. 1, 2, 3 over and 9 up. You're going to do this on graph paper, and you can see why. It's very difficult without it. This is greater than or equal to. So greater than, like these numbers are up here. So again, I'm going to do the inside of this one. Okay. Then I'm going to graph the circle. The center is at -3, 0. It has a radius of 5. So 1, 2, 3, 4, 5. So it's going to come to here. And 1, 2, 3, 4, 5. It's going to come to here. And 1, 2, 3, 4, 5. Now this is going to look, it's not going to look like a circle. It's going to look like an ellipse because I have my scales different. 1, 2, 3, 4, 5. Okay? But I think you'll understand why if you're thinking about it. You know, I put these so much closer together just to fit it on there. And this says greater than. Okay, so the numbers greater than would be on the outside of this. Numbers less than would be in the interior of it. So the area, if I shaded all of this out here, where does it overlap here? It overlaps in this section right in here. Okay, so this becomes my answer. Okay, I hope that's helpful.